Why would thousands of tiny ants decide to turn their own bodies into a living bridge? Imagine you're walking through the rainforest and you spot a line of army ants moving with military precision. Suddenly, they reach a gap, a space too wide for a single ant to cross. You'd expect them to stop, hesitate, maybe scatter. Instead, something extraordinary happens. A few ants at the edge grip the leaves with their claws. Then others crawl over them, hooking onto legs, mandibles, even antennae. Within minutes, they form a chain that stretches across the gap. More ants march across this living structure, using their own sisters' bodies as a roadway. Then, once the column has passed, the bridge disassembles. The ants climb back into the swarm as if nothing happened. No blueprint, no overseer, no command. And yet, the result looks like an engineered bridge. That's the puzzle. How can creatures with such tiny brains cooperate in such an elegant way? And what does this reveal about the way our own brains might work? The answer is a story about emergence, about how simple rules at the individual level create astonishing intelligence at the collective level. And to see it clearly, we need to zoom out and think in analogies. At first glance, an ant looks like the last place to search for wisdom. Each one has about 250,000 neurons. Compare that to a human brain, which has around 86 billion. By any measure, an ant is simple. And yet, when you gather hundreds of thousands of ants, something clicks. They behave as if they are one single organism, a superorganism. And this is the first big insight. Ants don't build bridges because any one of them knows what a bridge is. They build bridges because each ant follows simple rules. If I feel traction beneath me, I hold still. If my legs are pulled, I grip tighter. If there's space, I climb over my neighbors. That's it. No master plan. The bridge is not designed, it emerges. And this idea of emergence is what ties ants to the human brain. Think about your brain for a second. None of your individual neurons knows what you are thinking. A single neuron doesn't hold a memory of your grandmother's face. It doesn't decide whether you're hungry. A neuron fires or it doesn't. It passes a signal along to its neighbors. Each one follows simple rules based on chemistry and voltage. But when billions of them fire in vast patterns, the result is thought, memory, creativity, and consciousness. In a sense, you are your own colony of neurons, and your mind is the living bridge they create. Let's go back to the ants. Imagine them approaching a stream. If the gap is small, only a handful of ants stretch across. If it's larger, more ants join in, extending themselves until the connection is complete. But here's the magic. The bridge adjusts dynamically. If the colony is rushing and needs to save time, the bridge gets longer, straighter, more direct. If the colony is conserving ants, the bridge takes a shorter route, hugging the terrain. The ants don't calculate equations. They don't weigh pros and cons. But the final result is an optimization, as if the colony has done math. And that's exactly what happens in your head. Your neurons don't understand calculus or language in isolation, but when they fire together in coordinated networks, they solve problems that no individual unit could handle. This is why scientists often call the brain a swarm of cells. The comparison isn't just poetic, it's precise. Both systems run on decentralized control. Both systems use local interactions to create global intelligence. Both systems adapt in real time to obstacles, rerouting pathways until a solution emerges. And here's the moment that should make you pause. When you admire the intelligence of an ant bridge, you are really admiring the same principle that makes your own thoughts possible. Let's dig deeper into the mechanics. Ants use their claws and mandibles like grappling hooks. Once the first few ants stop at the edge, they essentially sacrifice mobility to become infrastructure. Others pile on. The combined weight presses the lower ants into the surface, creating stability. But the bridge isn't fixed, it's fluid. Ants can crawl in and out of the structure while others maintain tension. This makes the bridge self-healing. If part of it collapses, nearby ants reattach and restore the link. Now, think about your brain. Your neural connections aren't fixed either. Synapses strengthen or weaken depending on use. New pathways form when you learn. Old ones fade when they're unused. The structure of your thoughts is like a living bridge, constantly rearranging itself to keep the traffic of signals flowing. Both systems show resilience not because they are rigid, but because they are dynamic. One of the most astonishing experiments in entomology showed that when given two possible routes across a gap, ants self-organize into choosing the path that balances efficiency with colony cost. They create a bridge that is not the shortest possible, but the best compromise between conserving ants and saving time. They find an optimum without ever calculating. Similarly, your brain often finds solutions by balancing trade-offs automatically. You don't consciously optimize every step when you walk. Your neurons adjust muscle signals on the fly, finding the best pattern. You don't calculate probability distributions every time you catch a ball. Your neurons fire in networks that approximate the math for you. Emergent optimization is a shared trait of both systems. Here's where the analogy really deepens. Imagine the colony as one giant brain stretched across the forest floor. Each ant is a neuron. The pheromones they leave behind are like neurotransmitters, guiding the flow of activity. The bridges they form are like neural pathways, carrying the colony's thoughts across obstacles. When you watch ants, you're essentially watching neurons in slow motion. And when you look inside your own brain, you're seeing an invisible colony, billions strong, weaving living bridges of thought across the gaps between your cells. This perspective flips our usual idea of intelligence. We tend to think of intelligence as something that lives in individuals, a smart person, a genius animal. But the ant bridge shows us another form. Intelligence can be distributed. It can live in the connections, not the parts. Your neurons alone aren't smart. Your ants alone aren't smart, but together they are brilliant. This is the secret of emergence. The whole is smarter than its pieces. It's the same principle that makes cities function, ecosystems adapt, and the internet grow. Local actions, global patterns, small rules, big outcomes. And maybe this is why we find living bridges so mesmerizing. They are a physical metaphor for our own hidden inner workings. They remind us that what feels like unity is often a dance of countless small interactions. You don't consciously command your heart to beat each second. You don't consciously adjust every blink or breath. These are emergent behaviors, like the ant bridge. Your sense of self emerges too, from billions of neurons firing in chorus. And seeing ants do something similar gives us an external mirror of our own mystery. But the story doesn't end there. Scientists studying these bridges discovered something even stranger. The ants don't just make a bridge once and repeat it identically. They experiment. Sometimes they start one configuration, then adjust midway. Sometimes they dismantle one section and rebuild at a better angle. This flexibility hints at a kind of collective learning. The colony isn't hardwired. It adapts, remembers, improves. And this is another direct link to brains. Your neurons aren't static. They shift connections in response to new experiences. They learn patterns. They adapt to injury. Both systems evolve on the fly, constantly rewriting their own structure. If this seems mind-blowing, that's because it is. It forces us to ask, where does intelligence really live? Is it inside the individual parts, or is it in the relationships between them? The ant doesn't know it is part of a bridge. The neuron doesn't know it is part of a thought. And yet, together they create something larger, something almost magical. That's the hidden truth. Intelligence is not a property of one unit. It's an emergent property of many. And once you see it, you start noticing it everywhere, from traffic systems to flocks of birds to the neurons firing right now in your head. So what does all of this mean for us? First, it means that intelligence doesn't have to come from a single powerful brain. It can emerge from a crowd of simple units working together. That idea changes how we think about problem solving, design, even technology. Take computer networks. The internet doesn't rely on a single controller to function. Information hops from node to node, rerouting automatically if a cable fails. Just like ants reroute when a bridge collapses. Just like neurons reroute when part of the brain is damaged. The resilience comes from the connections, not the parts. Or think about cities. No mayor designs every intersection or predicts every traffic jam. Yet from millions of independent choices, drivers picking roads, shops opening at certain times, deliveries weaving through, patterns emerge, rush hours form, neighborhoods specialize, the city adapts. That's a giant living bridge of humans. Emergent intelligence is all around us once you start looking. Now here's the really mind-bending part. If ants can form a living bridge without knowing it, and neurons can form a thought without knowing it, then maybe our own sense of self, our identity, our I, is another emergent illusion. Just like the bridge isn't one ant but all of them together, maybe you aren't one neuron but the chorus of billions firing in patterns. That doesn't make the bridge less real, and it doesn't make you less real. It makes you part of a bigger truth, that consciousness might be what happens when simple units organize in the right way. The bridge shows us that intelligence and even identity can emerge without a master plan. Scientists studying ant colonies often point out that there is no single ant in charge. There is no queen brain giving orders. The queen lays eggs, but she doesn't tell anyone what to do. Each ant reacts locally to its neighbors and environment. The intelligence is in the interaction, not the hierarchy. Compare that to your neurons. There is no central neuron that acts as a boss. No single cell says, "Now we remember childhood," or "Now we solve this math problem." Instead, patterns of activity spread across networks. Your thoughts are the product of those interactions, just like the bridges are the product of ants locking legs. Once again, local rules give rise to global understanding. Let's play with a simple analogy. Imagine a choir. Each singer follows a score, singing their notes. No single voice is the melody. It's the blend that creates the song. If you isolated one singer, you wouldn't hear the full piece. In the same way, one ant is not a bridge and one neuron is not a thought. But together, with enough numbers, the music appears. The choir is to the song what the colony is to the bridge and what your neurons are to your mind. This is the essence of emergence: beauty from simplicity, order from chaos, bridges from bodies, thoughts from cells. Another fascinating angle is adaptability. If you block one path, the ants quickly reorganize and form another. They don't panic. They don't need a meeting to discuss strategy. They adjust. Your brain does the same. If one area is damaged, other areas can sometimes take over functions. Stroke patients relearn to walk or speak by rerouting neural signals. Plasticity is just the brain's version of ants shifting their bridge. Life thrives by adapting, not by being perfect the first time. Ants show us that flexibility is intelligence. This leads us to an aha moment. Perhaps the most powerful systems in nature aren't the ones with the smartest parts, but the ones with the best connections. Ants are tiny. Neurons are simple, yet their networks achieve things that would look impossible from the perspective of any single unit. This is a lesson for us as humans too. Collaboration, communication, and connection often matter more than raw power. A single genius might fail where a well-connected team succeeds. A single neuron does nothing, but billions of them together create a symphony of thought. So the next time you see a trail of ants outside, don't just think of them as little scavengers stealing crumbs. Imagine them as a visible metaphor for your own brain in action. Every step they take, every link they form, mirrors the hidden dance inside your skull. Living bridges of ants carry colonies across gaps. Living bridges of neurons carry you across thoughts, memories, and ideas. The same principle underlies both. Intelligence is not a spark in a single unit. It's the fire that spreads when many sparks connect. And here's the practical takeaway. When you face a problem that feels too big, too complex for one mind, think like the ants. Break it into smaller actions. Connect with others. Build networks that allow solutions to emerge. Intelligence doesn't always come from top-down planning. Sometimes it comes from the bottom up, from local rules and collective action. That mindset can reshape how we build teams, how we design technology, even how we understand consciousness itself. In the end, ants teach us a profound lesson. We often look for brilliance in individuals, but nature shows us that the deepest intelligence lies in systems, in connections, in emergent behavior. The living bridge is not just an insect trick, it's a window into how complexity creates meaning. It tells us something about ants, something about brains, and something about ourselves. That we too are networks of tiny units, weaving bridges across the gaps of existence, creating something larger than the sum of parts. If this idea sparked even a small wow inside you, imagine how many more wonders are waiting just beneath the surface of everyday life. That's what we explore here on How It Actually Works. So if you want more living bridges of curiosity, more keys to unlock the hidden patterns of the universe, make sure to like this video, share it with a friend, and subscribe. Because the more minds we connect, the more intelligence we can create together. And maybe, just like the ants, we'll discover that the greatest ideas are the ones we build collectively.